Hello everyone and welcome to day 14 of solving LeetCode problems until I'm hired by a FAANG company. Today we're going to be solving 1823, find a winner of the circular game. So there are n friends that are playing a game. The friends are sitting in a circle and are numbered from 1 to n in a clockwise order. More formally, moving clockwise from the ith friend brings you to the ith plus 1 friend. For I is in between 1 and n, and moving clockwise from the nth friend brings you to the first friend. The rules of the game are as follows. Start at the first friend, count the next k friends in the clockwise direction, including the friend you started at. The counting wraps around the circle and may count some friends more than once. The last friend you counted leaves the circle and loses the game. If there are still more than one friend in the circle, go back to step 2, starting from the friend immediately clockwise of the friend who just lost, and repeat. Else, the last friend in the circle wins the game. So given a number of friends n and an integer k, return the winner of the game. Okay, like just looking at this, especially this sentence makes me want to think that we should at some point use the mod operator, but still let's look at example 1 here real quick. We have a group of 5 friends and k equals 2, right? So here are steps of the game. So start friend 1, count 2 friends clockwise, which are friends 1 and 2, right? So 1 and 2. This one leaves the game. Then it's going to be 3 and 4. This one leaves the game, right? 5 and 1. This one leaves the game. 3 and 5. This one leaves the game. And yeah, 3 would be the remaining friend. So we should return 3 indeed. Of course, we could just probably use here the mod operator and just keep counting, but we do need to keep track of which are our friends that are out. Of course, the logical way to solve this would be using a linked list, a circular linked list, right, in which we would just keep iterating through this same rules until the node and node next is the same value. But I believe we can do better than that. We can hopefully not use as much memory and also try to be a little bit more efficient than that. Like one other approach that I'm thinking here real quick, even though I believe it would not be very efficient, is create an array with all of our friends, right, which would be 1, 2, 3, 4, and 5, if n is equal to 5, obviously. And what we could simply do here is just keep iterating basically k mod n, right, where this is going to be equal to 2. So, right, 2, k equals 2. So 2 mod 5, this is 2 mod 5 is going to be equal to 2. So our second element, we should just pop it using the pop function in Python, reduce 1 to n, and just keep iterating, right? However, the pop function in Python requires, it's not constant time to run that. So this would basically make it, like if we created this algorithm, the time complexity of this would be O of n squared. So that's definitely not the optimal approach we want for this algorithm. I'm sure we can do much, much better than this. Okay, so I can't seem to find any other solution actually. So I'm going to quickly look here into the discussion section and see if there are any tips that would help me. Okay, so people are agreeing on the circular linked list, but looks like I require some kind of knowledge about this problem, which I don't really know, to successfully solve it in linear time. And I believe that's a little bit too complicated. So actually, I am just going to do my approach, the linear approach, not even using the circular linked list. I'm just going to use the special array, right? And the pop functions is probably not going to be as fast. Yeah, we're simply going to need here our array. This is going to be equal I for I in range of 1 to n plus 1. So while n is greater than 1, we're going to keep iterating. Of course, every time we're in a while loop, we're going to return to decrease n by 1. In the end, we're going to return the only element at array. So return this. And here we're simply going to do that the index is going to be equal to I plus k mod n. We should actually just decrease it by 1. And also this should actually be I. Then we're simply going to do r.pop at I n minus equal 1. And I believe that should be it. So let's see what happens if we run this. Okay, so these two test cases have been accepted, and let's see what happens if we submit this. Okay, and there it is. We have successfully completed day 14. Our algorithm, as you can see, beats around 70% of users. This is basically the same thing as using a circular linked list. We're just taking advantage of the pop function in Python. And yeah, well, that would basically be it for this problem.